So, what on earth does a 19th century warrior have to do with the future of your job? Well, it turns out a whole lot more than you'd think. Today, we're diving into the world of artificial intelligence, using Oliver Theobald's Machine Learning and AI for Absolute Beginners as our map. And believe me, our journey starts in a very unexpected place.
Now I know what you're thinking. A quote about the samurai and an explainer about AI? But stick with me, because this perfectly captures the kind of massive, society-shifting moment we are all living through right now. It's a story about what happens when the skills you spent your life mastering become, well, obsolete, almost overnight. The story of the samurai. It's really a powerful warning for any of us whose job relies on knowledge. It shows us exactly what happens when a brand new technology comes along and just completely rewrites the rules of the game. And when you lay it out like this, side by side, the parallels kind of chilling, right? The samurai were the elite knowledge workers of their day, but their entire world was turned upside down by steam power and modern armies. Today, you've got professionals, lawyers, marketers, artists, coders, all facing a similar shakeup from AI. The samurai had a choice, adapt or vanish. And for us, well, that question mark is hanging right over our head.
You know, history gives us a pretty big clue here. The samurai who actually made it through this transition weren't the ones who fought against the new technology. Nope, they were the ones who figured out how to work with it. They found what you might call a missing middle, a new space where their human judgment and skills could be amplified by the power of machines. This points to a future of collaboration, where we don't just use AI, we actually partner with it.
Okay, so that little history lesson really sets the stage. But what exactly is this new technology we're talking about? AI is a term that's thrown around everywhere, so let's get really clear on what we mean when we say it.
The best way to think about AI is not as a single thing, but as a huge, overarching mission. It's the big umbrella term for any attempt to make a machine do something that we would normally consider smart. You know, that could be anything from your phone recognizing your face, to a program translating a language on the fly, or even composing music.
Now, one place people get tripped up is the difference between AI and data science. It's pretty simple when you think about it like this. Data science is the detective work. It's about sifting through tons of data to find clues and insights. AI then takes those insights and builds a system to act on them automatically. So one finds the why, and the other builds the what.
So if AI is the goal, how do we get there? I mean, you can't just program a computer and type in "be intelligent" line by line. The real magic, the big breakthrough, happens when the machine starts to learn all on its own.
See, the engine driving almost all modern AI is something called machine learning. And here's the key idea. Instead of giving the computer a massive, rigid set of rules to follow, we just give it a ton of examples and let it figure out the rules for itself. It's all about learning patterns directly from data, not just following orders we wrote down for it.
The whole process is actually a lot like studying for a big exam. First, you have the training phase, where you feed the system thousands and thousands of examples, let's say pictures of cats. From that, the system builds a model, which is just its internal mathematical idea of what catness is. Then comes the test. You show it a new picture of a cat it's never ever seen before. The goal isn't for it to have memorized the training photos, but to actually understand the concept of a cat well enough to recognize a new one.
Okay, so to make this whole learning thing work, you really only need two fundamental things. You need a recipe for how to learn, and you need the ingredients to learn from. And that's where algorithms and data come into play.
It's really that simple. An algorithm is the recipe that tells the machine how to learn from the data. But without data, the fuel, the most brilliant algorithm in the world is just an engine that's not going anywhere. You absolutely need both, and the quality of each one is everything. And these recipes, these algorithms, they aren't all created equal. On the left, you've got something like a decision tree. The logic is super simple, right? It's a series of if-then questions that are really easy for us to follow. We can see exactly how it made its choice. But then you look to the right. That's a neural network. It is incredibly powerful, but its decision-making process is so tangled and complex that we often call it a black box. We can see the amazing result it produces, but the internal process, it's a total mystery.
And that brings us to maybe the single most important rule in all of AI, and our source material says it perfectly. Garbage in, garbage out. It doesn't matter how great your algorithm is, if the data you feed it is bad, your results will be bad. If you train a model to predict house prices but you only show it data from a single rich neighborhood, it's going to be completely wrong everywhere else. The model is only ever as good as the data it learns from.
And this is what good data really means. It's not just about having a lot of it. For instance, if your data is missing recent customer purchases, that's a completeness problem. If a customer's age is listed in years in one file and months in another, that's a consistency problem. Every single one of these little flaws can contaminate your fuel and cause your model to spit out results that are totally off the rails. So, we've talked history, we've gone through the definitions, the mechanics, and it all leads to the one huge question that's on everybody's mind. Where is all of this going?
All right, right now, today, every single piece of AI you interact with, Siri, ChatGPT, you name it, is what we call narrow AI. These systems are amazing specialists, but that's it. They can't generalize. The jump from where we are now to that next theoretical step, artificial general intelligence, or AGI, that is a massive leap. We're talking about an AI that could learn and do any intellectual task a human can, and beyond that lies superintelligence, a level of smarts we can barely even wrap our heads around.
And that journey towards superintelligence leads us to a concept that sounds like it's straight out of science fiction, the singularity. It's this hypothetical moment in the future where an AI becomes so intelligent that it can start improving itself, which triggers this runaway, exponential intelligence explosion. Progress would happen so fast and be so profound that the future would become totally unknowable to us, a world beyond our ability to predict or even control. And look, this isn't just a fringe idea from sci-fi novels. Some of the most brilliant minds ever, like the late Stephen Hawking, have issued some really stark warnings. The core concern is this: if we create something that is vastly more intelligent than we are, we might not be able to control it. And if its goals don't happen to align with our own, the consequences could be catastrophic.
And that brings us right back to where we started, but with a whole new perspective. As we continue to build these more and more powerful systems, what is our real goal? Are we just forging a better tool? Are we creating a collaborative partner? Or are we, just like the samurai, accidentally paving the way for our own successors? The answer to that question is going to define the entire future of our species.